All right, just a little bit of a review. In the last 2 hours, we talked about how to link tables together, multi-table queries, so that we can use fields and data from multiple tables, tie them together to get the related items in other tables and combine these in any which way we want to. An example would be this query. Robert, can you get that door for me? Example would be this query here where I want some information from 3 different tables. I want to know where did we go, how much money did we spend, but I want to know who went. And if we look in the tables directly, select everything from the trips table, it doesn't tell me who, it gives me an ID. Now I could painfully go into the employee table and say select star from TBL trips where the employee ID is 1010101. But then I'm manually linking those tables together. The beauty of related databases, related tables in a relational database is that we can write queries that do that linking. So what I want, according to my little cheat sheet over here, let's see if I can get everything lined up at once here. I want the last name and first name concatenated. And I'm not quite sure if that's right, but we'll find out. And that's all I need from the employees table. And I want more fields, though, from other tables like the trip date and the expenses. But I also want to know, where do these people work? Now in this case we have 4 plants, and the 4 plant IDs are probably pretty easy to sort out after a while, but imagine a larger company with dozens of plants, and I see plant number 9 as a supervisor. I'm going, I don't know who the heck that is. Give me the real plant name. And while we're at it, just in case I want to call the foreman and say what's going on, let's add that. So let me check my field names here real quick because it's been a week or 2 since I looked at these. So here's TBL employees that has a first name, last name, so that's good. My plants table has a plant name and a foreman, so that's good. And my trips table has a trip date and a destination, so that's good. And expenses, yep, so that's there. So when we're combining data from multiple tables, the select clause just lists the fields. It doesn't matter what tables they're in, it just lists them all. What do you want? And this can be huge, can be dozens of tables. Then what we need to do is link the tables together, tell SQL how these tables are related. So I'm going to start from my employee table, and I want to link that, join that to the other 2 tables. Now this is where, for me, the entity relationship diagram comes in real handy because I want to see those relationships. The entity relationship diagram also tells me what the linking fields are. That comes in handy. That's why I like having those nearby. In this one, it's not too difficult. Employees work in plants and they take trips. So I want to link my employees table now. Let's start with the trips table because that's kind of how I have them listed up here. What I normally do if I have an ERD is just kind of follow down the chain. Sometimes the order you list the tables here doesn't matter. Other times, hint, hint, it does matter. The order you link the tables occasionally makes a difference. So if you're having trouble getting these queries to come up with the answers that I have in the result sets, first of all, email me to make sure I don't have the result sets wrong. I think I got them right now. But if you can't get it to match, try rearranging in maybe a little more logical order the tables and how you link them. This is particularly important when you have a relationship. Think about that relationship in one of the sample designs that we did where we had volunteers that had skills and we had positions that had skills. And these things, by the time you were done, they'd made a circle or a square. Well, if they make a circle and a square, there's probably a couple of different ways that you could relate those tables. And if one isn't working, consider going at it from a different direction to see if that helps you. There's no clear way for me to say this is the way you got to link them. I start with what I see in the entity relationship diagram or with how they're listed up here. I want to join that table. When you join tables, when you link tables together, the keyword is join. Technically, the keyword is an inner join because there are two kinds of joins. There's an inner and an outer join. The inner is optional. You then list the table that you want to join to. I want to join to my plants table. And then what do those two tables have in common? There's two ways to do this join. I'm going to show you both. Normally you wouldn't mix and match like this. The easiest way is to use the using clause. In the using clause, you then in parentheses, and you must include parentheses, include the name of the field the two tables have in common. So in this case, that's the plant ID. An employee works in a plant and a plant has an ID. That's the linking field if we looked at the ERD for this. In order to use the using clause, the linking fields have to have the same name. So if one of them was plant ID and the other one was plant number, it's perfectly legal to do that. It just makes this a little more complicated because we wouldn't be able to use the using clause. If I then want to join this, and this time I'm going to use the optional join without the inner, leave the optional inner out. Inners out, outer join, inner, saying a lot of words, inners and outers here, it's a little confusing. This keyword is optional, you don't need it. I feel it helps clarify things, so I tend to put it in, but you don't have to. So just to demonstrate that, I'm leaving it out in this case, and I now want to join that to the trips table. I could say, using employee ID, and that would be acceptable. I'm going to come back and change that one in just a minute. This is normally how I would do it. Actually, to be consistent, I would probably do it like this. The last thing that's listed here is I only want the trips to Chicago. So just to make sure this is working, I'm going to add the destination to my field list. How do I know my query's right? Sometimes you think the query's right. You don't put the destination in there and you don't see that there's some New Yorks that snuck in there for some reason. So what I like to do is put that field in here first, and then once I've verified that the Chicago filter seems to be working, then I remove it again. The joins come first, and then all the other clauses in the order you learned them in Unit 1 or in single table queries. The where clause, the group by clause, the having clause, and then finally the order by clause. Those have to still come in that order, but this is really just one big list of tables here, and one big list of fields. So at this point I do a where clause, where the destination equals Chicago. So the key to multi-table queries is list all the fields you want. Doesn't matter what table they're coming from. But then you must, in the from clause, link the tables together and designate to MySQL how those tables are linked. And then you can still include destinations, or I mean a where clause. You can still include grouping if you're doing statistics. Remember, group should only be used for statistics like sum or average or count. You can include a having clause, and you can include an order by clause. And if I wanted to, I could order by last name, comma, first name. Actually, I could order by, didn't I have employee name? Yep. This is perfectly legal. That's probably better. Remember that calculated fields, like my concatenated first or last name, first name here, the concatenated field, the calculated field is available. Its alias, that's what this guy's called. Its alias is available to having clauses and order by clauses, but it is not available to a where clause. It must have something to do with the way these queries are constructed behind the scenes, but that calculated alias is not yet available. So if we wanted to do a where clause on this name, we'd have to repeat the concatenation, repeat the equation. So let's see if that works. Nope. Select concat unknown column employee ID. Okay. Let's try that one. That's better. So now, again, I don't have a bunch of ID numbers here. I don't have a plant ID number. I don't have an employee ID number. I have human readable, useful information. Alex went to Chicago. His expenses were $883. That might be worth a call to Miss Compton to say, what the heck's going on? And so on down the list. That is my preferred way to link tables, but sometimes you don't always have that option. If, for instance, the employee ID, emp ID, was called employee ID in the table, in the employees table, but emp ID in the trips table, because whoever designed the trips table a long time ago was using an abbreviation, perfectly legal, we can still link them together, but we can't use a using clause. So now what I want to do, I'm going to highlight this for those of you following along. I'm going to copy it and paste it so we can kind of see both at the same time. I'm going to repeat the same query. But instead of using the using clause, I'm going to link the tables using an on clause. I'm also going to leave out the optional inners. When you use an on clause, you must specify how these tables are linked. The employee table is linked to the plants table on the plant ID. And so you have to say where the plant ID in the employee table is equal to the plant ID in the plant table. But that doesn't make any sense. Why wouldn't the plant ID be equal to the plant ID? We're really talking about the plant ID in two different tables here. When you use the on clause, often the field name will be shared between the two tables. You have to tell MySQL which one you're talking about. We could do this. It's called qualifying the field name. That's the plant ID that's in the employees table, and this is the plant ID that's in the plants table. Perfectly legal, hard to type. What most people will do is assign a short alias to every one of the table names. So for my employees table, there's an E, I'll call it E. For my plants table, I'll call it P, and for my trips table, I'll call it T. Then instead of the full table name, I can use its alias and shorten these things. Aliases do not have to be one letter long. They can be multiple letters, they can be words, obviously they can be the whole table name. They're just used to simplify these joins when we're using on. Now I want to link the trips table. It is also linked to employees. So where the E emp ID is equal to the T emp ID. Better way to read that is where the employee ID is equal to the trip employee ID. So it's another way to link tables. Sometimes you have to use this technique. I didn't know about the using technique until last year this time, or actually last semester this time. I've never seen it before. One of the students discovered it. I went, cool, got to put that in my notes because it makes life a lot easier. You don't have to qualify things. You don't have to create aliases for your table names. However, there's one condition, very important condition, in order to use the using clause. The linking field names must be the same. And that's not always the case. Today we're going to talk about joining a table to itself. Well, if we're joining a table to itself, we're linking one field to a different field. Those two fields can't have the same name. You can't link a table to itself using the using clause. Can't do it. Yeah.
When we're doing our queries, I noticed that you didn't use the as e for your table names. Do you want us using do you want us using as on our queries?
I don't put it in my table aliases. I do use it in my field aliases, but a couple of you have already discovered you don't need them there either.
Right.
I just think it makes it a little easier to read up here. I guess it's just what I'm used to. Because all of a sudden this is saying select contact, last name, comma, first name, employee. When I'm making a list of fields, that looks dangerously close to I forgot a comma for the employee field.
Right.
But this is perfectly acceptable for an alias. You don't need the word as, it's optional. But I feel, at least in the field list, that it makes it a little easier to read that that's an alias. With the table, if there's a letter following the table, I guess I'm used to that's the alias for the table. I've never done it. I'm guessing you're telling me this is legal. No complaints. The as's are optional. Up here, I think it helps the readability. Down here, I think it actually detracts a little bit. And so this is what I normally do, but if you leave them all out, I'll figure it out. Probably. Isaac?
So a non-clause is what you use. Well, you can't use it like this, or when the linking field is named differently each table.
You have to use it when the linking fields in the two tables are different.
Yeah.
Okay, plant ID and plant num, or plant number and plant num, or whatever. If they're different, you have to use this technique. So you need to understand both. In the homework assignment, I do not designate which one to use. My advice is stick with using, just because it makes life a little easier. What if I wanted to, for some goofy reason, I don't know why I would want to do this, but let's just pretend, display the employee ID. If I do that, I'm going to get an error. And it says column emp ID in the field list is ambiguous. That's what that says. I don't know who you're talking about. I can't tell which one you're talking about. If you include the linking field in your field list using on, you have to qualify it. Which one do you want? The employee ID or the trip employee ID? It really doesn't matter because they should be matching. Because if I can't see my results here anymore. So let me just put in an E here. Notice that even though I haven't defined it yet, this E is available to my field list. Now when I run it, I get my employee ID. Well, for this trip, if Alex took it, who cares if it's the trip employee ID or the employee ID? They match. That's what we mean by linking these. They match. So whenever you have an ambiguity, got two tables with the same field names in them, you need to qualify them. Otherwise, you'll get this ambiguous message that I got that basically says, I got two fields, same name. You didn't tell me which one. Okay, if I said, Miss Johnson, stand up, they'd be going, who's he talking to? I need to qualify that. Same thing when you've got field names here, if they have the same names. Again, that's why many database administrators like to ensure that throughout their database, every field name is unique. In huge databases, that gets hard to do. It's not necessary. If, on the other hand, I want to display the employee ID up here, where I did the using, I don't have to qualify it. Because SQL is smart enough to say, oh, if we're using, they must be the same, and it doesn't matter which one, so I'm just going to grab, I don't know which one it's using. Doesn't matter. So another advantage of using the using clause is if you do include a linking field up here, which is very rare, because what are those linking fields? Mostly auto numbers, right? Why are they important to somebody? I don't often include them, but if you need to, because the assignment says to, or the boss says to, I want to see that number, then put them in there. And if you use using, then you don't need to qualify it. If you use on, then you must qualify it. Steve?
Yes, in the option one there, the top line, the top argument where it says from employee, table employees, if you had gone ahead and did a dot E after that, or put an E after that as an alias, would that confuse it?
No, it just, you're not using it, so it's kind of redundant. And there are some mistakes in my notes that it just has not risen to the top of my to-do list to say, you don't need these. There's an S,
Yeah,
right?
that's the only.
Not using it.
Thank you. It doesn't hurt.
And same thing with the E and the C. No, assigning an alias, you can assign an alias to anything. And if you never use it, SQL say, well, this has a different name, but
Thank you.
never using it. So it's not a mistake, but I do need to clean up my notes. Because Jess wants them nice and clean for next year, right? Questions about joining tables together? Remember, there's also, you might see some, if you Google some of these things, you might see solutions that use the where clause instead of joins. I don't recommend it, but once upon a time, that's all there was. I don't know how long join's been around. I'm guessing 10 plus years, but there's still examples out there that you'll run into on the web for joining tables. This also joins a table. This says, give me these, notice the three table names are listed next to each other. Just in a big old long string. And then there's a where clause that says where the employee ID in the student table matches, or the student ID in the student table matches the student ID in the enrollment table. And the enrollment course number equals the course number. This also links tables together. But then what happens if you have a where clause, like where the destination or where the campus is Stevens Point? Well, you can't add a second where clause, so you add another and underneath here, and that works just fine. But to me, it's confusing. It's two different purposes. Where clauses, in my mind, are used for filtering. I don't want all the records, I only want the ones that meet this criteria. The joins are used to link tables together. So these are possible. They're in my notes in case you run into them. Some people still join their tables that way, but talking to my experts who have internships or who have jobs in the local software development companies, they're all using joins, not wheres. So I do not want you to use where to join tables when you do your homework assignments. We then talked about outer joins. And outer joins allow us to include records in one table that don't have a matching record in a different table. So give me a list of all the dates that each employee has traveled. And let's just put in here, it's just an example, so I'm going to use the employee ID and the trip date from TB, well, better yet, let's use the last name. And the trip date, a couple people with the same last name, sorry. First name, trip date from two tables. TBL employees, and where's the from clause go? Many of you have been stretching these out across the page. These are very hard for me to grade. I'm very grumpy on weekends when you all turn them in at the same time. If you split them across lines like this, your clauses, your select, your from, the having, the using, makes it a lot easier for me to decipher and grade. From TBL employees, joined to TBL trips, using the employee ID. If I run this, remember from last time, there's somebody missing. Because I am in this database. We added my employee record, but I'm so new, I haven't taken any trips yet. But that's very hard to see here, that who are my new employees that haven't taken. I want a list of every employee, regardless of whether they've gone on a trip, so that I can see not only who's gone on a trip and when, but who hasn't been on a trip. To do that, I need to join differently. I need to use what's called an outer join. Outer joins come in two flavors. There's no keyword outer, by the way. There's just the keyword left and right. The keywords left and right designate which table. The left table, if I were to string these together here, do you want the table on the left of the join to include everybody, or do you want the table on the right of the join to include everybody? Another way to look at it is which side of the join, left or right, is the parent. There should never be a child without a parent. That could happen. But often there will be parents without children, as in employees who have not taken trips. So if you're going to join here and you want all of the employees are on the left. So I do a left join. It's called an outer join. You can also do a right join if for some reason the employees table is on the right. I think one of the assignments requires you to, I give you a clue, link them together in this order, but then the big parent table is on the right-hand side. So you can do a right join saying, give me all of these. Now if I scroll through the list, there's that new employee. Oops, not there. Oops. My XAMPP failed me yesterday. So I had to reinstall it, which means blew away all my databases, which means Volkergall is gone in my database. How about yours? Anybody following? Did I show up?
Yeah, you're there.
Okay, so we'll have to trust me in the recordings here. I have not added myself back into the sample here. But that allows you to include people who have not taken trips. I could use the same kind of process to give me a list of all the employees and their plants. Well, what if a plant doesn't have any employees yet? Because it's so new. Do I want that in the list? If I do, then I have to do an outer join. What if I have an employee so new we haven't assigned him to a plant yet? It's a little more rare because the employee is a child of the plant table. But it could happen. We're not supposed to have children without parents. But maybe our application allows us to add a new employee and then assign them to a table, a plant, later. It's possible. I think I'm going to have to insert myself here. Remember, employee ID is not auto number in this table, so I can type in my own. I'd have to, pretty much. I'm assigning myself to plant number 1. Seems to have worked. Now if I come down here and run this again, there I am. Okay, so that's what you get. You're getting what trip? There's no trip. There's no trip date for Volcker Gall. I'm only going to show up once. Notice that Timothy here is showing up lots of times for his trips. If I've never taken a trip, I'm going to show up once with a null trip date. If there were any other fields here, like the expenses and the duration from the trip table, they'd all be null because there is no record in the trip table for me. But by doing a left join, brings that back in again. One of the things to be very careful of when you're doing outer joins, along with the criteria, where the destination equals Chicago. Now this is a left join, so I should be getting all the employees, even if they've never gone to Chicago. Should. But once again, where am I? And where's all the rest of these people? Because there were a bunch of, I know there's 50 employees, and down here I only have 25 rows included. If I did a left join, shouldn't I be getting all of my employees? You would think so. But this is a tricky little beast here. When you do an outer join, left or right, and there's a criteria, the where clause gets applied after the join happens. Okay, so it takes all those trips and all those employees and it includes Volcker Gall. But what's my destination if I've never gone on a trip? None. Null. Is that equal to Chicago? No. So it takes me right back out of the list again. In order to retain the left join and all the people whose data is null, you don't use a where clause, you use an and clause. What this says is join them together using the employee ID. Can I do this? Doesn't look like it, does it? So I'm getting an error here. Well, if I switch, now I'm going to have to switch to the on clause. So if it's a left join with a criteria, you got to do an on clause. Jeez, all these rules. There's no rules. You can make it easy. Just use on everywhere. But using's easier most of the time. Yep. Or you can do what I just did. Try it with a using. If it doesn't work, then switch. On. TBL, well, let's put the aliases in here. E and T. Where the E dot employee ID equals the T dot employee ID and, oops, that's what the where clause. On E, that goes up here. Sorry. That goes away. Now it's happy. So what this says is join them together as long as the employee IDs match, the employee and the trip ID, employee IDs match, and it's Chicago. So the Chicago is part of the join. Then it does that with a left join and says, oh, give me all the employees regardless of whether they've been to Chicago. Now all the employees are back. If this is getting complicated, we're just scratching the surface. The good news is it's about as complicated as it gets in the homework assignment, doing left joins with criteria, okay, or outer joins with criteria. It doesn't get too much more complicated than that in the homework assignments. But yeah, they can, these queries can get very, very complicated. Could scare you away by having Reen come up here and show me some of the queries that he's implemented for his Lions Camp projects. Right, Reen? Some pretty nasty ones in there. You just build them, it's like programs. You build them one piece at a time. You get it to do this, you get it to do that, and then you build, then you put in a criteria, and then maybe a group by, and you just keep building it in phases. Keep adding and more to it. Think of your single table queries assignment. Read the equation, read the assignment. Sometimes it gets a little complicated. Give me these 16 fields, but only where the destination is Chicago and the expenses are greater than 3, and I want those sorted by the expenses descending. And you could read that, and if you try to get it all in your head, it might be a little complicated. But you can build that query by simply giving me a list of these 16 fields. Everybody got it. Okay. Where the destination is Chicago. Verified. Yep. Got it. And the expenses are less than $3,000. Got it. Order by. You can just keep building these queries. And test them in pieces, just like you do programs. All right, I'm going to leave outer join. There's some other examples here, but I'm going to leave those and let you fight with them a little bit. If you're thinking about doing the multi-table queries assignment about 2 hours before it's due, think again. Multi-table queries assignment is probably the most complicated one that's left. The update one is not bad. All right, this is the complicated assignment in this class, at least for SQL. Do it in pieces. When you get stuck, ask me for help. Ask somebody else for help. And my advice is don't go 2 hours trying to figure it out on your own. That's admirable. But even in the real world, you get stuck, what happens? Talk to the person next to you. Happened to me yesterday. Couldn't figure out why my XAMPP wasn't working. So I called Green and Justin up here, and they both looked over my shoulder, and they said, I don't know. But so they weren't any help, but they did confirm to me that I wasn't doing anything stupid. You ask for help. I'm available. Sometimes the email response is a little slower than it's been in the past, but I'm still available. Ask for help. Another skill that you're not going to demonstrate in this class is the ability to look at somebody else's query and figure out what the heck it's doing. Jeez. Here's one. Right? Give me a list of the customers and their total amount that they've spent on in my store here, whatever the store is. From the customer table, join to the orders table. But I want a sum. That means I need a group by. I want a group by last name, first name. So if I have an Amiga Andrea and an Amiga Arnold, I get 2 different totals because that's 2 different customers. And then order them by total sales. Total sales is up here. So this is going to give me a list of all of my customers' totals, each customer individually. What's their total with the customer who spent the most at the top. Do the same thing down here, but only if they've ordered after April 1st of 14. Everything else is the same, right? And so sometimes when you're deciphering these things, no, that's it. That's a mistake, isn't it? I thought I fixed that. Here's a using clause with an and that didn't work, did it? Or did I do it wrong up here? I don't think I did it wrong up here.
The using should be on.
Yeah, the using should be on, and we would have to designate O and C and link them together. That's another mistake. Write that one on the board. So where am I? That's the examples for left join number 2. This is in set. This is just a note for me. And I might as well get rid of the extraneous aliases. Okay, so this isn't legal, I'm pretty sure. Can't test it because I don't have a table with customers that's readily available to me here with total sales. All right. Let's do some new stuff before this day ends here. Joining a table to itself. Unfortunately, the databases that we have, Premier Products, Henry Books, etc., don't have any self-join tables that are required. Okay, but just as a discussion, and I don't have a self-join here. Maybe next year I'll modify the employees table so that it has a link to the supervisor inside there. Then that table's linked to itself, right? So if I go back to the board, it's the recording. I go back to the board, I now have my TBL employees with a primary key of emp ID, but a linking field of supervisor ID. It's not a key. This table is a one-to-many relationship to itself where one supervisor has many employees. Make sense? Could we, some of you have split the supervisors up? Well, then what do I have in this table? A first name and a last name and an office phone number. And what do I have in the supervisors table? A first name and a last name and an office phone number. It's the same thing. Supervisors are employees, so the easy way to do this is to link it to itself. But if I needed to join those two tables, and we're pretending now because I don't have these tables, if I wanted to join these two tables, I'd have to do something like this. Select the first name, last name of the employee, and give me the first name, last name of the supervisor. That's not good. Okay. From TBL employees joined to TBL employees. Because that's what that is up there, right? It's a line, employees joined to itself. I can't use using though, can I? Why not? They're different field names. My linking field, my supervisor ID points back to an employee ID. Supervisor IDs are linked to another employee. If I am employee number 17 and my supervisor is employee number 1, where do I find that supervisor's information? In the employees table. It's just a different number in that table. So I can't use using for two reasons. Number one, the two fields have different names. And number two, because these tables have the same. How can I join a table to itself and leave the two table names that way? I can't. Provide each one of them with a unique alias. And now these aliases allow me to say, this is the employee, and I could say this is my, let's just make this E. And let's make this one soup. Just because it starts with E doesn't mean I have to give it an E name. I can. But this is my employee and this is my supervisor. So this is my employee's first name, my employee's last name. And now by giving good aliases to my tables down here, this makes a little more sense. If you're typing along, I hope you're just planning on saving it because there's no way we can run this because there's no supervisor field here. So now we've joined the tables. Because the field names are different, we have to use the on clause. And how do I link them together? Where the employee ID equals the supervisor ID. Where the supervisor's employee ID equals the supervisor ID. I think I have to put as supervisor ID E there. Isn't that a little funky? What does this say? Where the supervisor's ID is the same as my employee's supervisor. So if my supervisor is number 4, this says my employee ID is number 31, let's pretend. But what I'm saying is E is me. That's me, the employee. My supervisor is number 4. Go find the employee, the supervisor whose ID is number 4. You see why a lot of database administrators like to avoid self-joins? Joining those together can be complicated. I can't demonstrate this. We don't have any self-joins in the homework assignment. Yes, we do. But for a different reason. There's another reason to do or to join a table to itself. It's to compare two or more records within a table to each other. One of the assignments says, give me a list of the products that we have that are in the same class. Which products do we have that have the same class? Keep them together. The example I have here is give me a list of the employees who went on trips together. I could list everybody, right? So this one we can do. So I want the employee ID, so I want to select the employee ID and the trip date and the destination. Where the trip date and the destination are the same. So two employees going to the same place on the same day. I'm assuming they traveled together. Well, I want two employee IDs. The first employee who went on this trip and the second employee who went on this trip. That's not going to work. That'll cause me trouble, right? As it turns out, I'm asking the trip table to link back to itself. Give me a record and the matching record where the trip dates are the same and the destinations are the same. It's two records out of the same table that I want to link together. Yeesh. How do I link the table to itself? Well, we did that up here. Give each table a unique ID. So I'm going to say from TBL trips T1 joined to TBL trips T2 on. In this case, the linking fields have the same name, but they're in the same table, so I can't use using. So I have to use the on, where the T1 destination equals the T2 destination. So that says, give me a list of records, employee pairs, by the way, where the two people went on the same trip. And the T1 trip date equals the T2 trip date. They went to the same place on the same day. Now, if I generate this, let's see what this does. Gives me an error. Emp ID is ambiguous. Oh yeah, up here. This is the employee from the first trip, and this is the employee from the second trip. The trip date's also redundant because this is the same table linking back. They both have trip dates. Here it doesn't matter because they're going to match, right? Our rules say where the destination and the date are the same. So whether I pick T1 or T2 shouldn't matter because they're going to be the same. Okay, this says, and let's try to put an order by clause here, that'll help. But this says that this employee and this employee went to Philadelphia together on that date. This employee and themselves went to, well, it's true, right? Because the way what happens here is behind the scenes, the way I picture this is there's two complete duplicate copies of the trip table. This is the way I envision it. It's probably not the way, I hope it's not the way it happens, because that would be huge. But there's two trip tables. So we said, find me corresponding records in these two copies of the trip tables where the destination and the date are the same. Well, I'm in the first copy and I'm in the second copy. That's not good. And then here's another trip where this person went with me on that day to Dallas. This person also went with me on that trip to Dallas. And what's also bizarre, if I look a little lower, there's a 288 or a 1010. This is where I want to sort them. Let's order by trip date and then destination. I can order by. Okay, so here's this person going with themselves to Cleveland. Here's this same person going with 288 to Cleveland. And here's that same record, right? The same pair. We just flipped them. Kevin's going, what the heck? Well, remember, there's two copies of the table. So I envision it. And so if there's two copies of the table, and here's employee number 1 who went to Chicago on 2-4. Here's employee number 2 who went to Chicago on 2-4. And here's employee number 3 who went to Indianapolis on 4-7. When you join a table to itself, the way I picture this is we get a duplicate of this. And now we're saying link them together wherever the destination and the date are the same. So we start with this one. Does it match that? Yep. So we get a 1 Chicago 2-4, and this one is also 1 Chicago 2-4. Let's link them together. This is 1-1 going to Chicago on 2-4. Okay, how about this one and that one? Does it match? Yes. So that is 1-2 going to Chicago on 2-4. How about this one and that one? Match? No. Different day. So then over here we go to the next record. 2-1. Do the Chicago's? Yes. So now we get a 2-1 going to Chicago on 2-4. 2-2. Yeah, that matches. 2-2 going to Chicago on 2-4. Oh boy. This one match, no. Does this one match? No, no. But we also get that 3-3 went to Indianapolis on 4. Well, that's that. Kevin's rolling his eyes. Says, that's not what I want. So now the question is, how do we fix this? What I want to do is get rid of the duplicates. Here, I got 4 records. Let me just leave those. Right? I've got 4 records that are really the same pair of people going on this trip, right? So how do I get rid of the duplicates? By looking at the employee ID numbers, the primary keys, and saying, only give me the results if the first employee's ID is less than the second employee's ID. You can say greater than. Don't say equal to, because then you get these guys, right? Don't want that. I only want them if the first employee ID is less than the second employee ID. So I add another clause. And the employee ID for the first trip is less than the employee ID for the second trip. That takes out all those duplicates. If you look at the example on the board, and for those of you who aren't here listening to the recording, sorry, could have typed those, I suppose. There's got to be some benefit for coming to class. Okay. But what this does is gets rid of the duplicates. because there's only one record up there where the first employee ID is less than the second employee ID. So now when I run these, I get, boy, it looks like all these people went together on this trip, but they haven't left yet. Maybe it's a planned trip. I don't know why there's a 00 in the database. I haven't got a clue. Might be an error in my data. Here's these two people went to Atlanta together. Notice that the reverse doesn't show up. These two people went to Dallas, New York, 2-3 to New York. Here, I can tell here that there are 1, 2, 3 people that went on that trip together. Couldn't I get them all on the same line? You have to link this table to itself 3 times. And put even more clauses in to get rid of duplicates. So now this tells me what I need to know. 2 people, 3 people went on the same trip. Employee number 3 went with employee number 4. Employee number 3, 4. Wait a minute, where am I here? Employee number 2 went with employee number 3. Employee number 2 went with 4, and 3 went with 4. They all 3 went together. This is all I'm looking for. But this asks a question that we can't answer. We're using just a regular join. Give me a list of the people who went on a trip together, because each of the trip records for each person is a separate record. So a join can't solve that. A regular join. To do a self join, join the table to itself to compare 2 records in duplicate copies of the table to see if they match. I think you'll do 1 each of those for Henry Books and Premier Products. So there's only 1. And you'll see something like where the categories are the same. In this case, where the destination and the trip date are the same. Takes 2 criteria. What do you want to be the same? And then an extra AND clause to wipe out the duplicates. That one always uses the primary key. So it takes 2 clauses. In this case, 3, because I said destination and trip date are the same. I don't think the ones in the book ask you to do that. I hate to ask for questions here, but I'll ask. Do another one. Okay. Give me a list of the employees who work in the same plant. A couple of ways we could do this, right? We could say select everything from TBL plants, order by plant ID. No, TBL employees. Order by plant ID. There, here's all the ones together. There's a guy who doesn't work anywhere yet. I thought I assigned myself to, oh, there it is, plant 1. Here's all the ones together. Here's all the 2s. So that kind of gives me the answer, right? But if I wanted the list of every set of employees that work in the same plant, this is a little funkier. If I wanted to link them together and show them as pairs, how would I do it? That's what they're looking for in the book. Give me a list of the products that have the same price. Each pair of products that has the same price. Each pair of products that are in the same category. If I wanted a list of each pair of employees that are in the same plant, I would say, so, and what do we want to know? Maybe what plant they work in. Let me start with plant ID. I'll see if I can make plant name work. And I want the employee's first name and last name, but there's 2 employees that work in the same plant. So I want the first name and the last name of the other one. Employees that work in the same plant. I'm going to have 2 copies of my employees table here because that's where my employees are. From TBL employees, When you join these, when you do these self joins, this is an example of a self join, there's always two copies of the same table. So now this is the first employee's name. This is the second employee's name. And when we're done, they're both going to work in the same plant. So whether I use E1 or E2 here doesn't matter. I could list them both, right? But if my query works, those two numbers are always going to be the same. So listing them twice is kind of redundant, but I'll do it just as a demo. Now I have to say how to join those on. I want them to have the same plant ID. E1.plantID equals the E2. Notice I'm not joining them on the primary key. This is the employees table. I'm not joining them on the primary key. I'm joining them on what I want to be the same category, the same price, the same destination, the same plant. That will give me duplicates. There's always a second criteria, and the E1 employee ID, or let's just say plant ID. Yeah. No, the plant IDs are going to match. The employee ID of the first one is less than the employee ID of the second one. The second criteria always includes the primary key. How do you avoid duplicates? I'll leave that up there. Okay. So here's Louise and Tripper. They work together. Louise and Niles, Louise and Jason. Tripper and Niles. Well, if Louise works with all these people, then you could say there's more duplicates there. There's no easy way to filter that out. These are kind of bizarre, but they answer some questions that can't be done any other way, like give me a list of the people who went to the same city on the same day, who went on trips together. If we did that with just a regular query, kind of like I did up here, here's all the employees that work together in the same plant. If we did that with trips, we'd get a bunch of trips where one person went by themselves, and we'd have to filter those out somehow. I can't think of a way off the top of my head to filter those out. So this gets me closer. Self joins, two copies, same table, different aliases. What do you want to be the same for the homework assignment? What do you want to be the same? And then an and clause that gets rid of duplicates. Going once. Twice, three times. And the rest of that just explains it again. Can be done with a where clause, but again, don't use a join. Join the tables. Next topic. Subqueries. You've already seen these. in your single table queries, you did some subqueries to find a single value, to calculate a single value or determine a single value from one table and use it in the where clause of another. Give me the name of the employee who has the highest salary. We're actually going to do the same kind of thing here. We've already done one of these by embedding a select query inside of a where clause. I now need to know where the salary, come on, equals the highest salary. Well, how do I get the highest salary? Well, I could go into the database and I could sort it descending and look at the record and grab the salary and put it into this query. But if somebody else comes along later and gets a higher salary because of a promotion or a raise or whatever, my query is going to be out of date because I manually went to get it. What I want to do is say, in the current database, what's the highest salary? Well, the way we do that is to do a select clause. So I can do a select, and I'm going to end this one temporarily. Do a select clause and say, give me the maximum salary from the employees table. $81,000. Okay, who is that? By blending these two together, we can do that. Where the salary equals the maximum salary, but in order to do a subquery, you must surround the subquery with parentheses. This is identical, I believe, to what we did in single table queries, right? Okay. This is the introduction to subqueries. They can get more complicated. With the queries that we did in single table queries, the subqueries always returned one value. Give me the list of employees whose salary is $81,000. Now, there could be more than one, right? I could have 3 managers all making $81,000. This will return them all, as long as their salary, it matches that exactly. So there's all the information I need for the person with the $81,000 salary. So that's one use for a subquery, to base your list on some calculated value. Another very common one is give me a list of the people whose salaries are bigger than the average salary. As long as the subquery returns a single value. So I could calculate the average salary and say not equal to, but bigger. So who's making more than the average? Now, I'd have to run this query all by itself to find out what the average is, but I know there's 50 employees, and I've only returned, that's interesting, 14. Why is that interesting? Why is 14 out of 50 interesting? Karen, you're smiling at me. You know why?
Their salaries are
Fairly large, because I would expect the average to be somewhere around 25, right? I would expect the average salary to have 25 above and 25 below if it's the average. It's not what's happening here. That means that the people who are getting the big salaries are getting big salaries, and the people who are not getting big salaries are getting little salaries, and the big salaries are so big that it's skewing the average in a way, if you will. I would expect this to be around 25, 22, 20 maybe, but 14, whew. Because we got a lot of people making less money, and the average, there's a big split here. My guess is between union members and non-union members. And by the way, we can do that because this is just a query. Whatever you can do in a query, you can do in a subquery. including joining three tables together with an outer join with a having clause, etc. So if I only want the employees who are unionized, remember that's a Boolean field, so all I have to say is where union member. I don't have to say double equals true or equals 1. I can just say where union member. The one thing you don't normally do in a subquery is order by. The order doesn't matter. Because usually we're saying equal to or greater than, who cares what order these salaries come in, as long as we're greater than the average. And this is only returning 1. If it's only returning 1 value, why would you sort that 1 value? And notice, whoa, okay, this is still interesting. Notice there are some union members, so this gives me the average salary of union members. But notice there includes some management. Probably all of the managers get a higher salary than the average union salary. That's not what I want to know. So now I can throw a where clause in here. Oh, goodness. Where union member.
You already have it.
I already have a where and union member. So this is one criteria where the salary is bigger than the average and the person is a union member. That should take all of my zeros out. So give me a list of the union members whose salary is above average. For union members only. I got a bunch of ones. And again, I'd have to do a little research or just run this query all by itself to find out what that average salary is. When we started designing relational databases, I said that once we get this stuff built, any question you can dream up, we can probably come up with the answer. Give me the list of people who work in Coloma, because I happen to know it's plant number 1, whose salary is greater than the average of the company's union members as a whole. Not just the ones inside Coloma. This says, give me the average salary of everybody company-wide who's a union member, and then give me the list of people whose salary is bigger than that, but who are union members working in Coloma. Once the tables are built and related, if the data's there, you can ask the question. I have gender here. I can start sorting by gender and doing all kinds of stuff here. I don't have his number of kids, so I can't compare the salary on the number of kids. Don't have it. That I can't give you. But if the data's there, or if the data to do the calculation is there, I can write the query. And I can give you the answer. A lot of the stuff I've expanded on and dreaming up as I go. But they're logical questions, right? If I'm a manager at that plant, I might want to know, who do I have that's making more than the average union salary so I can give them additional duties, make them earn it. I don't know. But the data's there so I can ask. And this is why a lot of databases are so huge, because we put the data in there in case somebody might want to ask a question about it. Not because somebody said I need to ask a question about it, because they might in the future we add stuff. Gotta be careful with that. Equal to the max, less than the average. Give me the students who scored less than the average on the test. Give me the name of the person who made the largest donation to my cause. It's just like this one. What's the maximum donation? Give me their name. After you've seen a few of these, you can see that they get kind of redundant after a while. Oh, I've done that before. I've done that before. I think Joni said before we went on break that once you get done with Premier Products, then Henry Books is pretty easy, or easier, because you've seen it before. Oh, this is just like the one I did up there, and change the field names. Done. True. So I think the last thing we'll do today, we can also use subqueries to link data. Sometimes this is important. Here's a subquery that says, give me the location of the PC with the ID of the computer whose name is gateway. We must only have one gateway computer, because notice the where clause, that can still only have one ID. If we get multiples here, you'll get an error. So you gotta be careful. When you're using equality or greater than, you can only return a single value, like the average, like the max. In this case, like the ID number of the computer whose manufacturer's name is gateway. That one's scary to me. Show where the gateway computer is located. You can tell how old my notes are. We only have one. It's like saying, show me where the Mac is located. Today there would be hundreds or dozens. If this query returns more than one value, it crashes. The where clause is only comparing it to a single value, where it's equal to, where it's greater than. So what does this subquery do? It says, give me the ID number of the gateway computer, and then give me the location of the computer that has that ID number. So we're using it to link tables in a bizarre way. So up here it says, show the state that Volker Gall works in. Really? Volker Gall has a state? Simplify it here and just get the Gall, because I should be the only one. What's my state? I don't have a state. Uh-oh. Well, where do I get the state then? So where he works at? Oh, maybe it's in his plant table. Let's find out. Select everything from the plant table. Does that have a state in it? Yep. Okay. So now if I want the state where Volker Gall works, I can link these two tables together using a join or using a subquery. Let's start with a subquery. Here's my subquery. I want the plant ID, because I want to know what state. I need to link my plant table to my employee table. I want the plant ID from TBL employees for Gall. Where does he work? Plant number 1, or whatever it is. That's my subquery. Let's just run that. 1, okay. And now give me everything we know about that plant. Actually, I just want the state, right? Where the plant ID equals whatever my subquery sent me.
Semicolon.
Missing parenthesis, extra one. There we go. Thank you. Okay, so the subquery again gives me 1. This says, give me the state for the plant that has value 1. So basically we said where the last name is Gall. Yes, there's a Coloma, Michigan, as well as a Coloma, Wisconsin. Show the trips taken by Jakob Meiser using a subquery. Okay, first of all, let's run this again real quick here with just a join. Couldn't I just say select the state from TBL plants, joined to TBL employees using the plant ID where the last name is gone. Same answer. Isn't that easier? Probably. Why would I do the other one? It's an alternative. And occasionally this gets more complicated. And the joins get more complicated sometimes. This does provide an opportunity, potentially, to remove some of the tables that are in the middle. Remember what I said when you're joining tables? You got to join them all. If I need something from here and here, I got to join all the tables in between. There might be a way to get from here to there without all the stuff in between if I have something that they haven't covered. Maybe. Show the trips taken by miser. Okay. Using a subquery. Select everything from trips. But first thing I want to do is taken by miser, but what's miser's ID number, right? Because in my trip table, I need his ID number. So you might write, and I would recommend this, the subquery first. Select the employee ID from TBL employees, where the last name equals miser, and I'm just going to keep it simple and hope that there isn't a second miser, or, yeah, just keep going. And the first name equals Jakob. Should get one, right? You got one. Another good reason to write the subquery. If you get more than one answer, whoops, at least for today. Next time, more than one answer may not be so bad. So that's my subquery. And now all I want is all the trip information for that person. Select star from TBL trips, where the emp ID equals. Maybe not. Unknown emp ID in the where clause. What? Emple ID. All the employee IDs are the same, so that's a pretty good sign. Quick way to link. I don't need anything else from the employees table. Just the ID. All I need is the ID number. Don't need the name. Oh, it would be nice. Don't need the name. Don't need the social security number, those kind of things. All I need is the ID. This might be an easier way to do it. Again, I can solve this problem using a join. Notice I qualified my star. If you don't, you get everything from both tables. I just want all the trip information. Nice try. TBL employees on emp ID. TBL trips. Still not happy. Column emp and the emp ID in the there we go. Show the trips to Chicago whose expenses are greater than the average expenses for all trips. This cannot be done with a join, because the calculation for average has to be done first. There's no way to do that calculation first and then join the answer to another table. That has to be a subquery. Doing the homework assignment for part 2, just read carefully. If I ask you to use a join, use a join. If I ask you to use a subquery, use a subquery. If I don't specify, probably a join because it's probably a little easier. Stop there so you can rest your brains for programming logic.